I'm going to talk a little bit about even and odd functions, and I want to show several curves to illustrate the concept of even and odd functions. Okay, so let me draw my x and y axis. Okay, here we have this and this. Now, if we have a function and the function has the same values on the left side of the axis, it has a, let's say it's mirror image on the left side, like this, so that we have that if this is x, and this is negative x over here, then we have f of x and negative x are the same, so that f of x equals f of negative x. Then we say the function is even. So if the left and right sides are mirror images of each other, so left side, right side are mirror images of each other, everything over here has exact duplicate over there, then we say that the function is even. Okay, now the function is odd if here we have our axis. Okay, here's our axis. If the symmetry, instead of being left and right, so we don't have left and right symmetry like that, like we had in the previous case, but rather we have symmetry across these quadrants right here. So we have symmetry across there. So if everything here, let's say this is x, and this is negative x over here, okay? And if we have a situation where f of minus x equals negative of f of x, so here we have, this is f of minus x, this is f of x, and this is positive, has a positive value, and this has an equal but opposite negative value, then we say that the functions are odd. So even is symmetry across this way on the coordinates. It's everything on the positive side has a mirror image on the negative side. And odd is symmetry across this way on the coordinates. Let's look at some examples of even and odd symmetry for functions. To do that, I want to look at our grapher here. And the first function I look at here is y equal x squared. Here's the function up in this corner right here, y equal x squared. We look at y equal x squared, and we see that what we have on this side and what we have on this side are equal. We have a reflection, a mirror image across reflected across the y-axis. So that's an even function. And let's look at this function right in here. This function is x to the fourth minus x squared right there. Okay, this function also has symmetry reflected across the y-axis. What you see over there and what you see over here are the same, reflected across here. So that is also an even function. Now, this is y equal e to the x squared. Okay, that function right in here, that's the number e raised to the x squared power. Here's what this function looks like. This function also has symmetry reflected across the y-axis. So that's an even function. Another example of an even function here is y equal absolute value of x. See that right up there. Y equal absolute value of x. Again, symmetry reflected across the y-axis. That's an even function. Another example, y equal cosine x. Right here, y equal cosine x. has symmetry reflected across the y-axis. That's an even function. Now, how about this function right here? This function has symmetry reflected across the origin from the first quadrant to the third quadrant. Okay, this is odd symmetry, so that function is an odd function. Okay, now I could change that function to this function, minus x, y equals minus x, and do that. And the symmetry in this direction across these quadrants also means it's an odd function, because f of x is equal to minus f of negative x. So we still have that property that f of negative x is minus f of x. So symmetry across this way also represents an odd function. Let's look at this function. This is also an odd function because we have symmetry across this way, we have symmetry across this way, we have and both of those symmetries in this case. Okay, so this is an odd function. Let's look at this function right in here. Again, notice we have symmetry across this way. We also have symmetry across this way. That is an odd function. Let's look at this function. This is sine of x divided by x. This is an even function. Now, what is interesting about this function, let me zoom out a bit. What is interesting about this function is that the numerator is an odd function and the denominator is an odd function. But when we divide the two functions, we get an even function. Okay. Now, let's look at this one. This is sine of x divided by x squared. We have symmetry across this way. We have symmetry across this way. Notice these little parts over here. Okay, this is an odd function. Notice that in this example, the numerator sine x is an odd function, and the denominator x squared is an even function. Okay. How do I know that sine x is an odd function? Let me just add that as an example here. Add new equation. Okay, y equals sine x. Okay, there's y equals sine x. As you can see, that is an odd function. We have symmetry across this way. We have symmetry across this way. Notice these regions here and here. So that is an odd function. And as I just showed in this example, this is an odd function. Now let's look at another example right in here. Wow, this is absolute value of x minus x cubed. Boom. This has no symmetry this way, no symmetry that way. It is neither even nor odd. So those are several examples of even and odd functions.